Yep. All right. So, welcome to another new episode of Cooking with Unity. Today, we're going to be continuing our work on our tower defense game that we started on the last episode. If you didn't join us for the last episode, you can actually still follow along. You can go ahead and download the file at the social stream on the right, and that has everything we did in the last episode on it. So, here we are in our file, and I'm opening our test level, and let's see where we were at before. I think we got shooting just working. So you can place towers, the towers shoot, and the enemy paths through the area. So that's good. So we have something started here. So the first part of this episode, I'm gonna break form here a little bit and actually do a little bit of artwork on this. Normally we prototype things with just primitives and not much texture work, but I like to add it whenever it'll add readability for us. And so let's add some art to this a little bit, and we're also going to be adding a script that I didn't write, but I'm going to show you how to put it in there. There's a link on the right that I'm going to be going to very soon. Basically, what I want to do is I want to be able to illustrate where the enemies are going to be going. I need to actually show the path that they're going. And there's not a real easy, quick, and dirty way of doing that. But so since it's not quick and dirty in the first place, let's actually make it look kind of good. Um, so let's get started. Let's first go and deal with that link that is on the right there in the social stream. So there's this create plane thing. We're gonna need a quad, and a quad is just a quadrilateral. It's just a square basically. And unfortunately, for whatever reason, Unity does not include one. So I found this script that allows us to generate planes with various parameters, and including creating a basic quad. So this, thanks to Michael Garforth and Juan Manuel Palacios, I probably butchered both of your names. I apologize for putting this out there for people to use because it's a pretty good script. So it's on the Unify community, and so you can't just download the file. So I'm just going to show you how to copy and paste this into a new script file and get it working. So just grab all the code here, and we're going to create a new C# script called create plane. It has to be called create plane, or if it's not, you have to manually edit it a little bit. And we're going to open it up, paste all this into it, and hit save. And then finally, this is an editor script, so it needs to be in an editor folder. So we're just going to create a folder called editor. It can actually be in subfolders and stuff, just as long as it's in a folder called editor. And so now I'm just going to hit play to make sure that it compiled the file. All right, cool. And if we go into the assets create menu, oh wait, no, game object create other, there's now custom plane in here. That's entirely because of the script that we just added. Click that, and we're just gonna take all the defaults here and create, and this will be our little quad. So I'm actually going to, yeah, we'll just call this quad for right now. And I'm going to make a prefab out of it. And we're done here. I'm just going to delete this. And this is just prep for something we're going to do a little bit later. So now let's see. We're going to need a couple of art assets. As I said, what we're working on here is making it so that we can see the path and make it so the ground's a little bit more readable as ground, because right now it's just a flat color and that's distracting. So we're going to go on the internet using Google and get us some placeholder art assets. Now, when you're making your own games, please try to not use people's copyrighted work. And don't try, just do. Don't do it. Or if you do, get their permission, give them credit, etc. what I'm going to be doing is just getting some placeholder stuff. This is intended to be replaced with art that I'd create later. But it's really good to just do this if you're just prototyping up something really quickly, or if you're not really great artists like me. So first let's get something for the ground. So let's go with grass. Let's see what we can get. Images. And actually, let's make it. Let's give our game a little style. Let's do pixel grass. And say tile. And let's actually find something that's an icon size. There we go. That looks pretty good. That looks like some Secret of Mana stuff there. So first, let's actually see where this came from. Oh, someone made this. All right. So I'm doing this. I figure this falls squarely under fair use for an educational program. If you do use someone else's art, please replace it with your own later. Just don't release projects with other people's art unless you get permission. So thank you, Ninja Fro, for providing us with this cool little tile. Oh, why is it zooming in? Let's not do that. All right, let's just right-click it and save this to our desktop. Desktop. And then, let's see, what else do we need? We need an arrow. I decided that I want to give a direction that the units are going in, so let's get an arrow. Arrow. Alright, so I want an arrow pointing up, and I'll get into that later, why I wanted it specifically pointing up. I guess we could always rotate one if we needed to. That looks pretty good. White's good because it allows us to tint it if we want to change the color in our shaders. So let's see this. Alright, so findicons.com. Alright, thank you, findicons.com. And let's see, what else do we need to do? That'll probably do for right now. And I'm gonna quickly do a quick edit on the arrow here. This may or might not be as easy on whatever your machine you're using. I'm using a Mac here, so we've got Preview, and Preview has this really awesome feature called Instant Alpha, which allows you to just basically cut out portions of an image and make them into an alpha mask immediately. I'm going to do a quick and dirty job on this. So. Alright, so we have just an up arrow now. I'm just going to save that. There we go. We have our little white up arrow. Doesn't look beautiful, but it'll work. And we're going to drag both these files into our Unity project. So let's get it over here. And they're PNG files, so they just drag right in, which is nice. So first of all, let's put this texture on our grass here. And the first thing you'll notice is this kind of is blurry and stretched and stuff, and we're going to fix both of those really quick. First of all, since it's a pixely tile, because we did pixel art style, you're going to probably want to do point filtering on this. This will make it so it'll have a crunchy look. It's already looking a little bit like Minecraft here. I hate to use that comparison, but everyone knows that game at this point. So yeah, so there's a little bit of a Minecraft feel to it. And we can make it tile a little bit too. So we have our, this automatically created a material for us when we dragged it in. So yes, apply. So we can go ahead and change the tiling on this to, yeah, we'll do like, I don't know, 8 and 4. Does that look about right? That looks good. And so now when we hit play, we have a little bit more of a background that we're working on. Kind of obscures our towers, but not really. That looks a hell of a lot better than the white thing. So now we got half of that figured out. the other half is making that path visible. So we have our path through objects script here, and what it does is we attached it to the enemy. That'll work. We're gonna have to change this around when we have multiple enemies, but it's not a big deal. So we have this path through objects, and it has our path points on it. And so I'm gonna just modify it so it creates some little path icons, basically, the arrow that we made specifically, to kind of show us what's happening. And we'll see if this actually works. I haven't actually done this yet, but I have a pretty good plan for how to actually make this work. So what we're going to want is, right now we have these objects, and you can't really see them very well, but they're the waypoints, and they're where the enemy goes through. Where's the... Oh, yeah, player base is what we called the final waypoint. So we have these waypoints, and what we want is we want to have something that goes between these points and shows us the direction the enemy is going. And so what we're going to do is we're going to basically create one of these quads, and I'm just going to drag this in for right now so you can see how this works. And we're going to basically orient it automatically, mind you, but I'm just going to show you the basic theory of what we're doing. We're going to orient it along the path and then stretch it out so that oh, not global, local, no, not move, we want stretch. There we go. We're going to stretch it out along there so that it'll basically kind of show our path, and it'll have our arrow on it in such a way that it makes sense. Alright, so actually let's fix our arrow real quick here. So I just dragged it onto the quad. You may do this later if you're doing it, if you're following along, but maybe I'll just follow along with me. So I just dragged that onto our quad, and that created this new material. So we want to change the material properties slightly. The shader we want is something that has transparent in it. So transparent cutout should suit us well. So transparent cutout, diffuse. There we go, and you can see our arrows there. We're going to want to modify our tiling a little bit so that there's basically a path being shown. But that's the theory on what we're going to be doing here. So, and the trick is just making that automatically happen. So I'm just going to leave this texture at 1-1 tiling for right now. And we're going to delete this quad. And we're going to make sure that we didn't... Okay, so the original quad hasn't been changed. So let's look into our script here and our path through object script and see how we can add this. So we're basically going to create these at the start. We're only going to need to create them once. So the logic will probably go in our start function here. And because it's going to be a chunk of code, I'm just going to create a new function to do it. So we're going to call function. I haven't made it yet, but so we get to name it right here. Let's call, let's see, create movement. Let's create the function first. Just put it right here. Void create move path objects graphical. Let's do that. Create graphical path objects. And we're gonna make this a do we need to make this a static function? Probably not. Let's just do that, and we'll see if we can just call it here. Create graphical path objects. All right. Hit save. So this does nothing currently. This just calls this function and does a whole lot of nothing. So now we need to figure out our logic here. So first off, let's create a reference to our path objects. So public game object, no, not array, just game object, graphical path object. It's probably over descriptive, but it's better to be over descriptive than under. Rule of thumb, if you've reached 80 characters for a single variable name, you've gone way overboard. All right, so the theory of what we're doing here is, as I showed, we were creating objects and scaling in between. So since we scale from the center of our object, we're going to need to find the center points between each pair of paths. So between the basic enemy. Okay, we'll just assume the initial enemy position as a path point. We'll probably reorganize this a little bit when we do multiple enemies. So we'll assume the first position. Then this waypoint is the first waypoint is the next position, next waypoint. And so between the first position and this position, we want to figure out something right in the center here, and then scale to encompass the distance between these 2 points. And I'm going to do this kind of using trial and error strategy like most of my stuff, so we're just going to work through it, and it should work pretty easy. All we need to do is just a little bit of math. So we have our object position here. So, and we're going to use that as the first point. So, let's see. So for the first loop, let's just do the first one first, and then we'll do our loop for the rest of the ones. So, the first one is between transform.position. I'm just writing this out just to keep this up together in my head. Actually, let's make it as a comment. Create object between transform.position and first waypoint. So, we're going to figure out the center point. So, let's create a vector 3. Vector 3 out. Path object position equals, and we need that midpoint. So what we need to do is just a little bit of basic vector math. If we take the position of waypoint 1, subtract the transform position, we will get a vector that represents that length there. And then we can take the midpoint of that vector, which is we can just take the half magnitude of that vector to get the halfway point on it. And then we just add that vector back to our initial point, and that should give us a point in 3 space that represents that midpoint. So, sorry if I'm using... this is not complex vector math, but it is vector math. So there's some small complexity to all of it. So let's see. We're doing path point 0 dot position transform dot position minus transform dot position. So that's our first path point minus our current position. And then we take the magnitude of that, we multiply it by 0.5f to get the halfway, and then we take all of this, and I'm probably using more brackets than I need, but I like to be safe. All of this we want to add back to our transform dot position. And I probably have this completely wrong, but we'll see how this actually works. So now we're going to instantiate graphical path object at path object position, and we're not going to worry about the rotation right now, so we're just going to do quaternion identity. that just means just zeroes out all of the rotations and stuff. So we'll see how this works first, and then we'll go from there. So let's see what happens. So first of all, on our script, we're going to have to actually fill in this graphical path object. And we don't want to fill it in with the quad specifically. I'm going to duplicate this quad, Command D or Control D if you're on Windows. And we're going to call it path arrow. And we're going to go ahead and put the arrow up shader on it. So we have this path arrow all set up. And then we're going to throw this into our basic enemies pathing script. Oh, wait, grabbed the wrong thing. Path arrow, drag that in here. And hopefully we hit play and this will actually work. Oh, we already have compiler errors. Cannot be applied to operands of type float and vector 3. What did I do? So... Oh, that's not how that works. So, so let's see. We got path points, transform position, minus transform position. That's a vector. Magnitude is no longer a vector. All right. So, oh, we don't need to adjust. We don't need to adjust the magnitude. We just need to adjust the vector. So. And actually, we don't even need the add transform position at this point. So let me just go over this again verbally, lest I confuse people even more than they need to be. I still want this bracket there. So what we're doing is we're now taking the two positions here, this position minus this position. So that gives us this vector. And then we're multiplying the vector by half, so it'll be half the size. Okay, we still need to add the transform position again to this, so let's do that real quick. Plus transform dot position. Let's try this again. So hopefully this will run this time. Bam! And that actually looks like the reposition. It's hard to tell because it's small, but that's the halfway point, I think. So, math for the win. All right. So, yeah. So that's good. We got that working. Now, what we're going to want to do is we're going to want to orient it and make it a little bit bigger so that we can see it better. So, our orientation is going to be towards the goal point that it's pointed at. So we can do that by what are we doing? We need to basically change this third parameter here to something other than quaternion.identity. So I think quaternion has some really useful functions in it. So quaternion look rotation. What does this do? I think this is exactly what we want. Let's actually look at the information for this though. Quaternion look rotation. So what does this take for parameters? We don't need this anymore. Creates a rotation that looks along forward with the head upwards along upwards. Perfect. And it defaults to vector 3 up for the upwards portion. So that's good. So along the forward. Okay. Is there actually a look at? I swear there was a look at thing. Oh, we'll do look rotation. So we just need the forward vector. And we're going to do that using basically what we have right here. So this will give us our forward vector, our goal point minus our current position. And we're going to call this quaternion path object orientation equals. Then we're going to throw this into our third parameter here. So now it should actually be pointed the right direction, hopefully. So when we hit play here, we now have an arrow, and it's pointed the right direction. Now, this is part of the reason that I was looking for an upward-facing arrow. Our quad, when we created it, the default values on that create script creates a horizontally aligned quad, so it has an X component and a Z component. And that's great for us because Z traditionally is used for looking at things. Like we have this look, where is it? We have this quaternion look rotation. It assumes that the facing is Z, so we already have that on our quad. And because our quad is textured so that the arrow's pointing up, that's automatically pointing towards the Z. So that worked out really nicely for us. If it was pointing to the right, we'd have to either change the orientation a little bit or create like a parent object structure so that we can rotate it in. All in all, starting with stuff facing up is easier for this type of purpose. So, so now we have our arrow. It points in the direction, and it's in the proper position. You can even see that the unit moves right through it. So let's actually make it a little bit more visible and actually go the whole path. So we're gonna need to adjust the scale parameters of this, and there's nothing in the instantiate call that allows us to do that, but instantiate can return a reference, which we've done before. So game object path object, that's not what we call it. Okay, good. Path object equals instantiate, and we need to actually cast this, so as game object, and we wait for my computer. All right, there we go. I did give my computer a restart at the start of this episode, so hopefully it will not start acting up this time. So now that we have our path object, we can go path object dot transform dot scale. Local scale will be fine. Equals oh, we'll probably need a temporary variable for that because we can't just change the X or the Y or whatever. So let's do that real quick. Vector 3 new scale equals we're only going to be adjusting the Z, so it'll equal, let's just equal vector 3 dot 1. So that's 1 in every aspect, so that's a basic scale there. And then we're going to adjust the new scales dot Z to be, what would be appropriate for this? Since our quad is 1 unit, that's good. I think what we're going to want is just kind of what I was getting ahead of myself before. So this gives us our vector between the 2 points, and if we give it a magnitude here, this should give us the exact number that we want. And then we actually adjust the local scale to be the new scale. So let's see if this worked. We should have a big arrow pointing where we want to be. And it's working. I think it's actually working right. The reason it's not going exactly to the center and exactly to the end is because our texture actually, it was an arrow in the center of a texture, so it's not end to end. And that's going to be okay because we're going to actually change it to be multiple arrows, and I think it'll look fine with that. Let's also, by default, let's see. Let's actually change the... no, let's not change the width. That's probably fine. So we now have an arrow. Let's actually make it multiple arrows, though. Let's make it an arrow every unit. So let's see. Path object dot renderer dot material. We're doing some new stuff here. So new material here. So PathObject.renderer.material allows us to change the properties of our new object's material, and we can change the tiling on it. And when you change the material internally, it actually creates a new version of the material, so you're not actually changing it on every object. So all we're going to change is the y. No, what is it called? Oh, main texture offset. So do we want the offset? No, we want the scale. So main texture scale dot x. Oh, yeah. So we're gonna have to create another temporary thing. Maybe we can use the new scale. Will that work? No, that won't work. All right. So we're just gonna do one more thing here, just to make this a little bit cool and pretty. I spent a little more time on this than I wanted to, but that'll be fun. So path object, transform local scale, new scale. All right, so we're gonna need a vector 2. What do we call that again? I'm gonna look at a material just to see what it's called again. Tiling. It's called tiling, but that's not actually what it's called internally, is it? Material dot whatever. Oh, render dot material dot material dot scale, main texture scale. So we'll call it new texture scale. New texture scale. And we're gonna make this equal to vector 2.1 again. And then we're going to adjust the Y scale to actually be less than what it currently is. Right now it's 1 in one direction and 1 in the other. And we're gonna want it to be however big it needs to be to cover that ground, assuming 1 unit sized textures. So how do we do that? We're gonna need this information again. It's gonna be, let's see, new texture scale dot y equals. This will actually be exactly what we need. So let's see. Oh yeah, and then we need to apply that. So path object dot renderer dot material dot scale, main texture scale equals new texture scale. So let's see if this does what I expect it to do. All right, cool. We have little arrows pointing through there. Not perfect, but it'll work. Why does that feel like it's so far off? Yeah, it's in the right spot. Good enough. Good enough for right now. Let's also make these things red or something. So let's just change this. The nice thing about using white textures is if you change the main color, it'll actually colorize it for you. So there we go. And let's do that for the rest of our points real quick. So that's our initial point, and then the rest of it we're just going to loop through and basically do exactly this. So for each, is for each appropriate for this? No, it's not. For int I equals 0. Actually, int I equals 1. I is less than, what is it? Path points dot length dot, path points dot count should be length. path points. I swear that there's a way to get a length of... Huh. I'm just going to type length. And obviously it's going to probably complain at me because it probably has a reason for complaining at me in the first place. Let's first see if this just compiles. Let's see if that works. It totally worked. I don't know why my autocomplete was not working properly for that. Any array like that should totally work. So with length. All right. So anyway, so the reason we're starting with 1, normally in most for loops you're going to do I equals 0. The reason we're starting with 1 is because we've already done the first point. Is that right? We'll do it between the current point and the previous point. Yeah, that'll work. So we're going to basically just copy and paste this and then try and make sense of it. And we're already going to have some problems because we're redeclaring variables. So I'm just going to reuse these variables that we've already created. And what are we going to do? So instead of path point 0, we're doing path points I. And instead of transform position, we're doing path points I minus 1. I hope you guys are able to follow along with this. This is a little bit more complex than what we've been doing in the past, but it's all stuff that you're going to be doing at some point anyway when you're making games. So this will give us our current point, which starts at 1, and our previous point. And then we want to do this again where it's our previous point's position. And and we're doing this again. Lots of copy pasta. Honestly, at this point, we should probably have these set up as variables. But I'm not doing that right now for time. Again, just copy this wholesale here. And one more time. And let's see if this magically just works right out of the box first time. Worked pretty good. All right. So now we have our path for our units. It could be prettier, but it's more work than we've typically done with textures. So how much time do we got left? We've got 22 minutes left. That's good. That's good. We can get some other stuff that's actually more game related done. So we have dudes that can shoot at these dudes. Let's add I don't know. Let's add some. Should we add the game objects to kill these things, or should we add game logic to make these only shoot in the radius? Let's do the radius shoot first. Considering if we start killing that thing, we're going to need to spawn more of them, and then we're going to have to reorganize code. And I think I'm going to save that for next time so I can be really mad at my past self for putting me in a bad position for the next episode. Alright, so let's make these things shoot in a radius. So we've got our basic tower script, and let's look at what we got. So all this thing does is as set rate, the fire rate, it just spawns these bullets. So what we want to do is we want to check. So this just grabs a random target. Well, not a random. It's very much not random. It just grabs the first available target it can find, and there's only one enemy right now, so we're not going to change the logic on this just yet. We'll save that for next episode as well. We're going to want to check to see if this enemy is within a radius of the tower. So, easy way to check that. Let's see. Probably a physics overlap sphere. So, let's put some comments here. Check to see if the... Actually, let's do get our enemy. Check to see if our enemy is in range. I don't know if I want to get ahead of myself on this right now, or if we should just start simple and then change it later. I've been doing so much to screw me later. Let's actually do this more appropriately. So, instead of getting our enemy just randomly, we're going to actually do a physics.overlap sphere. And what this does is it returns a list of colliders, which in turn can give us some game objects that are within this sphere. So, it's got a position and a radius, so we can just do that. Let's collider overlap sphere. So our position will be transform.position, which gives us our tower position. And our radius will be a variable that we're making right now. Public float fire radius. And we'll start this at, I think 5 is probably meaningful, so let's go with 5. So fire radius. That's actually probably excessive, but let's give it a shot anyway. Sorry, we're not going to need that. So what this will give us is all the objects that overlap. And so we're going to need a temporary variable. Actually, let's just do a for each around this. So for each collider col in physics overlap sphere. So this will iterate over all of our colliders that we've hit. So let's see. We'll just go for the first one that matches the enemy tag. So if col dot tag equals enemy, we're going to set that as our target. So our we're going to game object target. I'm going to declare it there. We're going to do target equals col dot game object, and then we're going to break out of the for each loop. So, and then we need to remove this here because it's already been declared, and we're actually not even using this line, so we're getting rid of that completely. And so let's see if this actually works. Oh, wait. So we need to actually find out if we have something to shoot at. So if target does not equal null, then we create our bullets and shoot our bullets. Alright, so let's see if this works. I'm going to put a tower way over on the right. Come on. Okay, compiler error. Use of unassigned local variable target. Um, okay, well, equals null. It's gonna be like that. I always thought that defaulted things. Oh well, better to be explicit anyway. Alright, so we're gonna put our tower down, and I'm guessing it'll probably start firing when it gets about here. Yeah. Alright. That was close. Alright, so, and it stopped firing after it got out of range, so that's cool. So now we have towers that actually obey a radius. That's awesome. Alright. Good deal. And actually, can we not place... No, we can still place directly on that. Oh, I know how we could fix that. I was thinking that our little path thing would make it so we can't place directly on it. And in order to get that behavior, we actually have to apply a collider on here. So create a component. Let's see, physics, box collider. Yeah, now we can't place things directly on the path. So bonus, kill two birds with one big old chunk of code. Alright, well that was fast. What's next? Let's see. Let's add the collision detection and kill the enemy off, and then maybe we'll do a little work to reorganize it to spawn multiple enemies. I don't think I have enough time for that, though. I hate when I have badly timed episodes like this. Alright, yeah, let's just get some collision working. So, when the enemy gets hit, let's see. So we don't have a basic enemy script, we just have the path through objects. So let's create a new script called basic enemy. We already have an enemy named basic enemy, let's just make it confusing as possible. So we're going to attach this to our basic enemy before I forget, even though it does absolutely nothing right now. And what we're going to do is we're going to set, once my computer's done here, we're going to give the enemy a health, so public float. Do we want floats or ints? I like even numbers, but no, let's do ints. Let's make it fun. Public int float. Sorry, wait, public int float. Public int health. Actually, let's call it initial. And let's make a private int health. Let's just use the public one. Let's just call it health. I'm sure there was a reason why I wanted to do it the other way, but we'll do it the other way if I need it. So public int health, and we're gonna make it so we're gonna do an on collision here. So void on collision enter. And we want this for our bullets. So do we have a tag for our bullet yet? No, we don't. We're gonna make one real quick. So new tag bullet, and then we're going to go ahead and actually tag that bullet. There's other ways we could have set this up, but let's set it up this way because we're already started. Collision. Alright, so if collision dot tag, no, dot collider dot tag equals and we'll just hard code it in for right now, bullet. If collision.collider.tag equals bullet, we want to subtract some health. So how do we get the health information from this? Let's just have it subtract 1 for right now. But we'll adjust it so the bullets can have different health values so that we can do balancing and stuff. So if collision.collider.tag equals bullet, health minus minus, I'll just subtract 1 from our health. And let's start the health at 10 to start. We can always adjust that in the editor, but that gives a kind of meaningful number there. So health equals 10. And let's also destroy the bullet. So collision destroy collision.collider. I think that'll destroy the game object too, but we'll see. So this will make it so right now we kind of have the ping pong balls that just react and hit the ground, which is cool, but we wanted it to look like the enemy actually got hit by this stuff. So, and on this, if health equals 0, actually, let's be safer, less than or equal to 0. This would work in the other case, but as soon as we add health, like hit points or damage values to the bullets, it could screw us because we could overshoot 0. So if it's negative or 0, we destroy our little game object here. So game object. All right. That might be all we need to do. So let's see what we get. Waiting on my computer. Here we go. So if we... Oh, well, that killed it in a hurry. Huh. Oh, health is 0. Why is it 0? Oh, because we attached this beforehand. So, revert to prefab? No. Reset. And then let's apply this to our prefab too. Alright, let's try this again. Now that it actually has some health. Now let's look and see if our health is adjusting. It is 5, 4, 3, 2. And it got away. No! Alright, so let's put two towers out. And it worked. So destroying the collider didn't actually do what I wanted to do. So let me actually change it to collider.gameObject, because those balls were still hanging around. And I wasn't sure if that was going to work, but I wanted to see if it was going to work. So here we go. There we go. Now they're not bouncing around. And they died. Alright. And while we're in here, let's go ahead and do the logic so that... Because I'm not sure if you've noticed, but we have this out of range error once the thing goes out of the board, because it goes through all the waypoints and then it just tries to go to the next waypoint and it doesn't work because, well, it already reached it and there is no next waypoint. So let's fix that by making the enemy kill itself at the end, and we'll put a little note for ourselves to actually damage the player base once you get to that point. So it's not on collision insert, so it'll be on our path through objects. So update movement direction, speed, time, on trigger enter. So let's see, path points, current index. Alright, so if current path index is greater than path points dot length. Oh, it shows up that time. Alright, so path points dot length if it's greater than that, we want to destroy game object. And in here, we're going to have destroy game object and add logic here to deduct health from player / base. So let's see if this actually worked and solves our little problem. So it gets to the first point, yay, and moves there, and gets to the next point, yay, and moves there. And hopefully just destroys, oh, nope, out of range. So we're going to make it into, oh, whoops, wrong thing. Greater than or equal to then. Sometimes you're off by 1. So, wait, what? Why is that complaining now? Oh. Let's do that. I didn't even know that was actually a thing. Probably some binary operator that I don't use very often. So here we go. It goes to the this point, and then to the next point, and then it goes away. Hopefully, it did. It still says index is out of range. Why does it still say that? Oh. Oh, I see. Else. Now we won't have any of these stupid errors. Alright. So let's see how this goes. Alright, so here we go. It paths. I'm going to shoot at it even though... Oh, those rings are colliding with things they shouldn't. Okay, that got rid of our error. Good. Let's, so I added a collider to these, so that it would actually collide and make it so we can't click and place things. But let's quickly go to our project settings, physics, and make it so that things don't collide with things that don't need to be collided. Oh, we didn't make layers for these things. Alright, let's make an enemy layer and a bullet layer. I usually end up doubling up and doing double duty between tags and layers, and I have not gotten a real good rule of thumb figured out for myself on how to use layers versus tags. So you'll see a lot of times when we'll have bullets and enemies in both slots, and I'll just set both just so I can use either or. In general, if you're doing collision stuff, you want to use layers. If you're doing stuff that involves other information that you need to pass, you'll use tags. But let's make the enemy on here, and let's make the bullet on here. We're going to save the scene because we haven't done that in forever. Bad Max. Don't do as I do. Do as I say. Save all the time. Because I got very lucky that I didn't lose any work. So we want bullets to collide with enemies. We don't want them to collide with bullets. We really don't want a lot of collision with anything in this thing. So let's just start. Default should always collide with default. I don't think that makes much sense anywhere else. I'm just going to clean this thing up. So we want default. Actually, default should collide with everything, just so that we don't screw ourselves. Alright, and enemies will collide with... Not enemies. Enemies will collide with bullets, and bullets should collide with enemies, and that covers both of those cases. So let's see if this all still works. So we shoot these. We shouldn't see the balls bouncing around anymore because... Okay, well, we still had... That's odd. I don't fully understand why that ball still found a way to bounce. Oh, because default layer. Um, let's actually make one more new layer for our path arrow. We're going to call this one no col. No, we don't want it to be no collide. Raycast only? I don't know. Yeah, I guess it doesn't matter. Let's actually just go back to our collision matrix and make it so that let's just leave it as this. We'll clean it up later. I'll be like, what the hell was I doing last episode? Anyway, thank you for joining us. This was Cooking with Unity. I'm your host, Max Moreau, and you can contact me, tell me what you liked about the show, what you'd like to see in the future, things you didn't like, whatever, at either pushypixels@pushypixels.com or Dragfire on Twitter. Anyway, thank you very much, and you guys have a good night.